Welcome to Study Loop.
So in this problem, we are given with three diagrams which represent a single reaction, and the reaction is A2 plus B2 in equilibrium with 2AB. So in first part of this question, we have to find out which of the following or which of the given reaction mixtures are is in equilibrium. So to find that out, we are given the standard equilibrium constant value for this reaction, which is 1.5. So what we will do is we will calculate the Kc value or the equilibrium constant value for each of the reaction mixtures, and we'll compare that with this value, and which of the reaction mixture has a Kc value which is similar to this value, that reaction mixture is already in equilibrium. So we know that the expression of Kc for this reaction will be, we have the product as AB, so that means we will have AB square, since we have 2AB and the coefficient will go as power, and and we will have this value over the concentration of the reactants. That means in the denominator we will have concentration of A2 and concentration of B2. So this is the equilibrium constant expression for this reaction. So for the first one, the value of Kc will be what? So we are said that the red circles or red molecules here are A2, the blue ones are B2, and obviously the red blue mixture ones are AB. So in the first one we have one A2, we have one B2, and we have 1, 2, 3, 4, 5, 6 of the AB. So we can assume the concentration of AB as 6 here, and it will be 6 squares since we have 2 as a power, and in the reactant part we have 1 times 1 since both the reactant molecules are 1, and from here we'll have a Kc value of 36. So the standard Kc value is 1.5 for this reaction, and we can see that this is way greater than this. That means this reaction is not at equilibrium yet. Now in second one, the Kc value will be, so in second one we have 1, 2, 3 of the products. That means we will write 3 square over, we have 1, 2, 3 of A2 and 1, 2, 2 of B2. So we'll write 3 times 2 in the denominator, and this will give us a value of 9 over 6 means 1.5. And we can see that this is exactly same as the standard equilibrium constant for this reaction. That means the reaction mixture 2 is in equilibrium. And then for 3 we will find the equilibrium constant again. So for this we can see here that in C we have, or part 3 we have 1, 2, 2 of the products are AB. That means the Kc value for 3 will be, on the top it will be 2 square on the numerator, and in the denominator we'll have 1, 2, 3 of A2 and 1, 2, 3 of B2. So in the denominator we'll have 3 times 3, so it will be 4 over 9, which will give us a value of 0.44. So this is the Kc value for the third reaction mixture, and as again, since it is not similar to the standard Kc value, that means 3 is also not at equilibrium yet. Now in the part C of this question, we have to answer how the other two reaction mixture which are not at equilibrium yet will proceed to the equilibrium. So to find that, what we have to do is we have to compare the values with the standard value. So this is the standard Kc value for this reaction, and for the reaction mixture 1, the Kc value we have calculated as 36. So A, a higher Kc value than the standard value means we have more product present in the reaction mixture. And if we need to reduce the value of Kc from 36 to 1.5, that means we need some of the product to go uh, in the reverse reaction to produce some of the A2 and B2, which will eventually result in uh, more values of the reactant concentration and in less values of the product concentration, and which will eventually give us a lesser value of the Kc, and this way the reaction mixture 1 can reach the equilibrium. So for the reaction mixture 1, reverse reaction rate need to be increased. So increasing the reverse reaction rate, we can reach the equilibrium for the first reaction mixture. And then for the third one, we have the Kc value as 0.44, which is smaller than the standard value of 1.25. That means we need to increase the value of Kc to reach the equilibrium. And how we can increase the value of Kc? Once again, from the Kc expression, we can see on the numerator we have the product concentration, and in the denominator we have reactant concentration. So if we have a Kc value smaller than 1, that means we have more concentration of reactant than the concentration of product. And if we need to increase the value of Kc, or if you want to reach the equilibrium, we need to increase the concentration of the product and we need to decrease the concentration of the reactant. That means we need more product to be formed, or forward reaction rate to be increased, forward reaction rate to be increased for the reaction mixture 3 to reach the equilibrium.